Good day everyone. You have learnt lines in two parts. Now today you are going to start with planes, part 1. What is a plane? A plane is a flat surface, that's all. This board is a plane. The wall is a plane. In your room, the floor, that is a plane. In space, there are infinite number of planes, right? In that, we call X, O, Y, Y, O, Z, Z, O, X. O is the origin, okay? These three are called the coordinate planes. We can in short call them XY plane, YZ plane and ZX plane. Just as you know there are X-axis, Y-axis, Z-axis, which are the coordinate axes. Okay. So here see, this is XOY plane and this is YOZ plane. This is ZOX plane. We can show only like this, but actually the three axes are mutually perpendicular. Okay. Now, let me tell you certain basic facts which you should know. That is, if you consider any point on the x-axis, any point on the x-axis, what will be the coordinates? Any point on x-axis means you will get x comma 0 comma 0. The x coordinate can be anything. The y and z coordinates will be 0. If you consider any point on y-axis, there what will be 0? The x coordinate and z coordinate will be 0. So you can say it is 0 comma y comma 0. Any point on the z-axis, okay, that will be the x and y coordinates will be 0 and z. Is it clear? Okay. Now, supposing there is a point in the xy plane or xoy plane, definitely the z coordinate will be 0 and x and y will exist, isn't it? So now, any point on xoy plane will have coordinates x comma y comma 0. Do you understand the difference? Similarly, any point on YOZ plane, that means which letter is not there? X is not there. So that will be 0. So you will get 0 comma y comma z. Any point on ZOX plane, that will be, which will be 0 now? Y part, okay? So you will get x comma 0 comma z. Are you clear with these two concepts? Because plane is a new thing for you, let us go a bit slow. So now first, what do you learn? What is a plane? What are coordinate planes? And what is any point on the three coordinate axes? What is any point in the three coordinate planes? Okay. Now let us move on to the next concept. Note down all the concepts in your notebook. Now the next point. Direction ratios of x-axis or any line parallel to x-axis are 1 comma 0 comma 0. Actually, direction ratios are proportional numbers, but we will simplify it, okay? Direction ratios of y-axis or any line parallel to y-axis are 0 comma 1 comma 0. Direction ratios of z-axis or any line parallel to z-axis are 0 comma 0 comma 1. See, all these basic facts only if you are thorough, you will be able to apply them in the sums and solve them. Okay. So now are you clear about the direction ratios? So now you have learnt regarding coordinate planes, any point on the three axes, any point in the three planes. Now you have learnt about direction ratios. Okay. Now the next concept. Okay. Now projection of a point. What is the meaning? It is the foot of the perpendicular. Okay. So projection of a point x, y, z, a general point in space on x-axis. If you draw a perpendicular to the x-axis, you know, in x-axis, the y coordinate and z coordinate will become 0. So, the projection will be x, 0, 0. Immediately, you can say the rest, isn't it? Projection of a point x, y, z on y-axis is what? 0, y, 0. Projection of a point x, y, z on z-axis will be 0, 0, z, right? All the three. Okay. Now, once you know the foot of the perpendicular, immediately we can find the distance. Distance always mean perpendicular distance unless it is specified otherwise. Okay. So now, distance of the point x, y, z from the x-axis means actually it is the distance between these 2 points, isn't it? We have to use the distance formula. So you will write root of x minus x the whole square plus y minus 0 the whole square plus z minus 0 the whole square. So what will you get? Root of y squared plus z squared. Similarly, you can derive the result, isn't it? Distance of the point x, y, z from y-axis, that will be root of z squared plus x squared. Distance of the point x, y, z from z-axis will be root of x squared plus y squared. If you understand the basics, that is, if you know this point, naturally you can use the distance formula and you can get this. No need of by-hearting all these things. Now, this is about the axis. Now, projection of a point x, y, z on xy plane. You know, in xy plane, the z-axis, that is z coordinate will be 0. So that will be x, y, 0. Now, when you find the distance here, it is root of x minus x the whole square. That part will become 0, right? Plus y minus y the whole square. That will also become 0. So, z minus 0 the whole square will be z square. You have your root. So, you will simply get an z here. So, the distance of the point x, y, z from xy plane is z. Now we can derive the result for the other two, isn't it? What is the projection of a point x, y, z on z plane? The x coordinate will be 0, right? So you will write 0, y, z. Then you can calculate the distance. So all of you write this one, write the other two formulae. Then write this one, write the other two formulae. Similarly for this, then you will get a clear idea what is projection of a point on the axis, what is projection of a point to a plane. That is coordinate plane. We are concerned only about that. We will learn the distance for other things later. Then, distance of a point from x-axis, y-axis, z-axis. Distance of a point from xy plane, yz plane and zx plane. Okay? Is this concept clear to you? Fine. Now, any line perpendicular to a plane is called a normal to the plane, because that is very important. You should know it. Any line perpendicular to a plane is called a normal to the plane. Now, this is a plane, right? Now, this line is perpendicular to the plane, right? So now, this is a normal to the plane. Similarly, I can have many normals, isn't it? So, normal is a line perpendicular to the plane. So, this is one basic you should know. Now, what is the general equation that represents a plane? You know, a straight line is represented by a linear ax plus by plus c is equal to 0. Now when you come to a plane, ax plus by plus cz, the d can be on either side. I am writing it for some reason on the other side. Ax plus by plus cz is equal to d. This represents the Cartesian equation of a plane. This is called a general equation. Some x, some y, some z, some d. Everything need not exist, but this is the general format. Okay? Here, this A, B, C represent the drs of the normal to the plane. Okay? They represent the drs of the normal to the plane. Only a line will have drs. A plane will not have drs. So the normal will have the drs a comma b comma c. Now, if I have this equation as Lx plus My plus Nz is equal to, I will give some other letter P. Now here, this L, this M, this N represent the direction cosines of the normal to the plane. Okay? You should know both the formats. But usually the sums they will give like this only. But here I will tell you what is the special. Lx plus My plus Nz is equal to P, where the L comma M comma N are the direction cosines of the normal to the plane. In that case, this P will represent the perpendicular distance from the origin to the plane. Okay? Origin to the plane. So, if you want to find the perpendicular distance from the origin, if it is given in this format, you have to convert it like this. You know from the drs how to find the dz. Anyway, I will give you an example sum. So, are you clear with these two? Now, let us see the corresponding Cartesian I have given the corresponding vector equations. Okay. Now, this I can write as r vector dot n vector is equal to d. Here this n vector is called the normal vector. Okay, this is the corresponding equation, vector equation. Corresponding to this I can write r vector dot n cap, because here no LMN are direction cosines. Here n cap is the unit normal vector. What is n cap? Unit normal vector. This is equal to P. But generally in your textbooks they would have used D. But I want to give the corresponding equations here. Okay. So here the n cap represents the unit normal vector. And this P is the perpendicular distance from the origin. Perpendicular distance from the origin. Okay. This r vector dot n vector is equal to d is called the scalar product form, because it is the dot product. We call it scalar product form. If you get of this form, that is n cap and p, where p is the perpendicular distance, this we call as normal form. This is called normal form. Generally, this is the name given. Okay. So, let me explain again these things. A general Cartesian equation of a plane is ax plus by plus cz is equal to d. I have already told you that d can be on either side. But for the format in everywhere, I have made it this way. Here the A comma B comma C represent the direction ratios of the normal to the plane. Okay. The corresponding vector equation is r vector dot n vector is equal to d. The n vector is the normal vector. This form is called the scalar product form. Then instead of the direction ratios, if we use the direction cosines, that is L, M and N, Lx plus My plus Nz is equal to P. Here L, M, N represent the direction cosines and P is the perpendicular distance from the origin to the plane. Okay. The corresponding vector equation is r vector dot n cap is equal to P. N cap is the unit normal vector. P is the perpendicular distance from the origin. This format is called normal form. Okay. Be clear about these things. Now I will teach you how to convert from Cartesian equation to vector and vector equation to Cartesian. How to find the direction ratios and how to find the perpendicular distance from the origin. Okay. You consider the equation x minus 2y plus 3z is equal to 5. You know this represents the Cartesian equation of the plane. This is of the format ax plus by plus cz is equal to d. Okay. Let me teach you how to convert it into vector form. Very simple. Now I can write r vector dot. Okay. The n vector, that is nothing but here the coefficient is 1. So it will be I cap. Okay. Here the coefficient is minus 2. So minus 2 j cap. Here the coefficient of z is plus 3. So plus 3 k cap. That is equal to whatever is given here. Right. That's all. So from this Cartesian form, we have now converted it into vector form. Is it clear? Now, if it is given in this format, what are the direction ratios of the normal to the plane? That is 1 comma minus 2 comma 3. These are the direction ratios. Right? Here, if they ask you the direction ratios of the normal, straight away 1 comma minus 2 comma 3, which are the coefficients of I cap, j cap and k cap. They represent the drs. Once you know the drs, you can find the dz's, isn't it? Now, if I want to find the dz's, I will write 1 by, then root of 1 square plus minus 2 the whole square plus 3 square. So, what will I get? 1 plus 4 plus 9, right? So, I will be getting root 14, comma, minus 2 by root 14, 3 by root 14. They are the DCs of the normal to the plane. Okay. So, here also the same thing. So, if they give you the equation either in vector form or in Cartesian form, you can convert one form to another, right? Then you can find the direction ratios. You can find the direction cosines. Hope you are clear with this now, right? Now, distance from any point x1, y1, z1 to a plane, note the format what I have written, ax plus by plus cz plus d is equal to 0. Here I have brought the d to the left hand side. Okay, yes. ax1 plus by1 plus cz1 plus d by root of a square plus b square plus c square, the whole mod. Distance will always be positive, so the modulus. Okay. Supposing instead of x1, y1, z1, you want to find the distance from the origin 0, 0, 0 to a plane ax plus by plus cz plus d is equal to 0. It is d by root of a square plus b square plus c square. The reason is the x1, y1, z1 are 0. So, these three terms will vanish. So, you will get d by root of a square plus b square plus c square. Actually, this Cartesian format is easy. Generally, you will have two formulae, that is both in vector as well as in Cartesian. I am teaching you whichever is easier to you. You can follow the other one also. So now, supposing I give you the plane equation as some 2x plus 3y minus z plus 7 is equal to 0, right? This is the plane equation. I want to find the distance from the point 1, 0, minus 2, right? So this is the question. So you know you have to make use of this formula. It is always better to write what is x1, y1, z1. What are a, b, c? If you write, no, there won't be any confusion. So now let me write, this is x1, this is y1, this is z1. My a is 2, b is 3, c is minus 1, d is 7. To use this formula, the d should be on the left hand side of the equation, remember. Okay? So now, the distance, that is the distance, we mean only the perpendicular distance. I have told you already. Always remember that. Distance always means perpendicular distance unless otherwise mentioned. So, distance is equal to ax1, that is 2 into 1. So, 2. Okay. Then by1, that will become 0. Minus 1 into minus 2. So, plus 2 plus d by root of a square plus b square plus c square. Then the whole mark. Now, what do you get here? You get 11 here. Then here you get root 14 units. If you want, you can rationalize the denominator or you can leave it like this. So, this is the way to find the perpendicular distance from the any point x1, y1, z1 to a plane. If it is origin, it is very simple, no? You won't get that. Only d will come and then divided by root of a square plus b square plus c square. That is very simple. So, have you understood how to find the distance? Now, if the equation is given in vector form, you can either convert it to Cartesian form and make use of this formula, or the perpendicular distance from the origin, it is very simple using vector also. But I would suggest that whether it is from the origin or whether it is from some other point, you convert it into Cartesian and proceed this way so that you won't be confused at all. Okay? For a plane ax plus by plus cz plus d is equal to 0, if another plane is parallel to it, then that equation will be ax plus by plus cz plus k is equal to 0. Only the constant will change and the rest of the terms will remain as it is. This concept you have studied in straight lines also in 11th standard. Okay? So, you should know the equation of any plane parallel to the plane ax plus by plus cz plus d is equal to 0 will be ax plus by plus cz plus k. You can use any constant, that will be equal to 0. Now, if you have two parallel planes, how to find the distance between the parallel planes? Okay. Now, let us consider ax plus by plus cz plus d1 is equal to 0 and ax plus by plus cz plus d2 is equal to 0. You know definitely these two planes are parallel. Only the constant is differing. Now, the distance between these two parallel lines will be d1 minus d2 by root of a square plus b square plus c square, the whole mark. That's all. So, the distance between two parallel planes is d1 minus d2 by root of a square plus b square plus c square. Okay. So, just one example sum for this. Let us take 2x minus 3y plus z plus 6 is equal to 0. This is one plane. Let me take another plane as 4x minus 6y plus 2z plus 9 is equal to 0. Okay. Now, these two planes are parallel. See, even though they are not same, 2 2s are 4, 2 into minus 3 minus 6, 2 1s are 2. So, they are proportional. They can be proportional also. Now, what I will do, I want a proper ABC, no? Otherwise, I will get confused whether to take 2 comma minus 3 1 or 4 comma minus 6 2. So, let me multiply this equation by 2. So, I get 4x minus 6y plus 2z plus 12 is equal to 0. So, I am getting this is my equation 1 and this is my equation 2. Don't be dividing this and bring fractions, okay? Now, we know this 1 and 2, they are parallel planes. So, how will I find the distance? Let us use the formula. Distance will be, this is the d1, isn't it? So, 12 minus d2 is 9 by root of a squared, that is 4 square, plus minus 6 the whole square, plus 2 the whole square. Then put your mark. Because d1 may be greater or d2 may be greater. Now you are getting 3 by root of, you will get 16 plus 36 plus 4. So 40, 56. So 3 by root 56 units. Is it clear? Okay. I think the basics are enough for today. We can do something more in the next video. So, hope you have understood whatever I taught today. Take down all the formulae and concepts I have told you and remember all the basics. So, let us see in the next part further formulae, concepts and sums. Thanks for watching the video. Share it with your friends and classmates.